Welcome to the first instalment of X Innovations webinars, where we want to talk about the digital thread in digital engineering and manufacturing. We are very pleased today to have Tim Clark joining us. Tim's a model-based systems engineer consultant, and we feel this is an increasingly important area within this sphere. So today, we are going to be talking about model-based systems engineering for our first installment. So firstly, Tim, could you give us a little introduction to yourself?
Yeah, of course. As Charlie said, I'm a model-based systems engineering consultant. Started off in the defense industry a good few years ago now, where I was initially working as a mechanical designer at Kinetic, working on a range of different aircraft there. That's where I got my taste for fast jets and all that kind of thing. Then moved to a company called Martin Baker to be a systems engineer, where I was working on ejection seats for 7 years, where that's kind of where I got my introduction to model-based systems engineering and became a bit of a convert to it. Was there for 7 years, did a lot of process development, working with that company to build their model-based systems engineering process and approach. And then in 2022, I left there to sort of become a consultant, work with a range of different companies. Worked in Turkey for a year supporting their aircraft projects, and have since worked on underwater weapon systems, eVTOL aircraft, missile systems, that kind of thing, sort of helping companies adopt that, let's say, digital thread approach in specifically around model-based systems engineering.
Brilliant. Thank you very much, Tim. And as we do here at XTI, it's about digital thread. That's like what we talk about. MBSE is a key part of this, and I think an emerging technology. So what we'd like to do is take some time to talk to you, Tim. So the spotlight's going to be on you. So very first, obviously, Tim, we know each other, and one of the things I found you do really well is you articulate what MBSE is well, because it's not easy. I've read a lot, I've watched a lot, I've talked a lot. It's not straightforward. So could you give a simplistic view of what is MBSE for maybe somebody who's new to this saying or this acronym?
I think for me, MBSE sounds like a complicated word, but for me, it's about capturing as much as you can of someone's engineering thinking and process. So all the stuff that, you'd say, a 30-year experienced engineer just knows that this is what you do, or this is how you design that part. It's about capturing that in a way that can be stored and also then approached and consumed by a different audience. So it's kind of a standardized way of, or not even a standardized way, but a way that works for your company and your engineering process to extract that information, that really valuable IP that typically got lost in the, that person retired 10 years ago and we don't know how to do that anymore. It's about capturing that and representing it in a language. So I typically use languages like UML, SysML. You can capture and represent your system. You can model your system in a way that's approachable, and then capture all those different inputs to the different stakeholders. So, you're not just working with your customer, you've also got internal customers, you've got internal designers, you have people who are going to be inputting to that system design, and build that system design and capture it so that, in 30 years time, as I say, I'm a defense guy, it's the time that these systems are 30, 40 years. Someone can look back and say, so why did they write that requirement? Why did they design the system like that? And what verification evidence is associated with that? Why did they do that? What tests did they do to prove that, so that they can look at it and go, right, I need to change that bolt, or, we need to change that processor. What do we have to do? What's our impact? And what does that look like for an engineering project? So I think it's just about taking a slightly more holistic view, moving away from documents. I know everyone loves Excel and documents, but moving away from that and moving into a more, my opinion, approachable and studyable is maybe the way I'd say approach, so that you've it all stored in one place, single source of truth, the good buzzwords that are used, but storing it all in a place where people can come back to it and they can understand it, and it's not, as I say, stuck in an engineer's head who's retired 10, 15 years ago. Sort of thing.
That's really important and good. And I think one of the things, my second question for you is, why is it important? Okay, so that segues nice. And one of the things which you mentioned there a couple of times, which we talk about a lot, is IP belonging in the individual's head and not in the process of standardization or captured, right? But yeah, so for me, nicely touching on what MBSE is. I know very high level. But yeah, why is it important?
Yeah, and it's interesting because I think also it's important because we've seen, I think, over, you've probably seen over the last 10, 15 years, there's been a growing adoption of PLM tools and understanding that we have to store data artifacts, whatever they are, CAD models, Word documents, in a way that can be retrieved, can be managed, can be baseline. And I think MBSE is almost like the other side of that, where you're trying to capture your engineering process and the way you arrive at your product in a similar way. Because yes, it's great having that CAD model and saying, look, we've got the CAD model, but if you don't understand how you got to the CAD model, then it's not, it can be useful, but it's not as useful as it can be. And I think it's that partnering up of the why did we design it that way with the digital artifacts you produce as a result of your engineering process, and it also lets you codify and sort of enforce good engineering process. So you can look at something and say, well, look, you've built this architecture, this you've designed the system this way. How have you arrived at that? And so that you're capturing your engineering decisions as well as your end product. But at a more holistic, just our end products, because the end products are useful, but they're not everything. They don't tell the story. And where MBSE is so powerful, it is telling that engineering story, as you could call it, to arrive at that product and storing it in a way that's baselineable, that you can have approval processes, you can do all the good, high integrity engineering that you want to do, while capturing it, rather than just relying on having people writing documents. Documents are great. Anyone can write a good Word document, but they are, when you have complex products, and the world is just getting more complicated. Certainly in defense, it's going from mechanical to digital to software-defined items. We're only getting more complicated, and you cannot store in your head the complexity of these things in a Word document. It becomes, it's like an n-dimensional problem. You've got to look at it from so many viewpoints that you produce the document, it'd be thousands of pages, whereas you can store it in an approachable model that someone can navigate through and bite-sized chunk it, I guess. Look at it from your own different angles to understand how it means how it answers your perspective, and then sort of rotate the model, look at it again, and sort of build that picture in your head without having to just conceptualize it all. So
it is. It's about. You hear people talk about storytelling, don't you? Which you pointed to there, and you have theories about problem solving, the 5 whys. Why? Yeah. It gives you that, and I think the case you talked about there, especially within defence, aerospace, where products are around for a very long time, but they're nowhere near what they started out at. So, and understanding that journey is critical, and with technology, right? Just every week, just evolving, and the reliance.
When you have these 40-year products around, F-35 says it's going to be around until 2070, maybe something like that. You managing obsolescence is one of these things where certainly defense and aerospace has been historically bad at. Obsolescence only becomes a problem when it's the problem, as in like, oh God, we can't build this anymore. And those obsolescence projects, when you haven't got the story around it, you're suddenly trying to unpick engineers from 20, 30 years. Why did we do this? Why did we pick this process? Or why have we got this? And it becomes an exercise in understanding the product, the engineers who designed it, and then designing the solution. What MBSE hopefully lets you do is kind of go, well, let's make those two first parts of understanding why it was done and the design, so that you can design a solution much quicker. Hopefully shortcuts those first two and let you get to your actually solving the problem more quickly, which is where its value can really be.
Yeah, fantastic. So with your experience, and you named some of the work you've done, and I obviously know personally from talking to some of the work you've done, where do you have some examples, or an example what we can talk about here, where you've seen MBSE obviously been introduced to the business and brought value to that product development?
I think one of the biggest powers of MBSE is when you're having kind of complex products, and a customer doesn't care about how you designed your PCB, say. They don't really care what processor you've selected. What they care about is, does the system do what I want it to do? Does it achieve the need I need it to meet? Is the range of the jet 1,000 miles? That's what I care about. what MBSE lets you do is you retain that narrative and that story all the way through your system. So when you get down to somebody picking what processes should you use, what fuel type are we going to use, what propellant are we going to use, you repeat that story. So, you know, for instance, the product I worked on was like a sensing board, like a safety critical sensing board, and it was looking at one of the sensors wasn't performing quite as well as we wanted it to, so it was a little bit out of spec. And it was understanding that, well, what does that? We had a specification on that sensor. Well, why did we arrive at that specification?
Mm-hmm.
And then what does that mean for the customer end result, which was essentially like a risk of injury to an occupant if that sensor was misperforming? And actually, what we could then have a discussion on is, well, if that sensor's 5% worse, what does that result in terms of the end customer need, the occupant injury rate? And when it was something like a 0.5% increased risk of injury. Now, that means you can go to your customer and say, look, we could spend a lot of time, a lot of effort to pick a new sensor, requalify it, do all of that work. Or are you willing to accept 0.5% increased risk of injury, but then maybe when we respin the product in 10 years, we can address it then. So it's kind of, you know, you can start having those actual tangible discussions with your customer of, yes, we've got a problem at the lowest level, but what does that mean in the context of your need? And that's the really, really valuable part. And it's what everyone is driving towards at the moment, which is when you have these complex systems, where they're systems of systems of systems of systems, how do you work with a stakeholder? How do you work with a customer when they say, you're telling me this bolt doesn't quite meet that spec? What does that actually mean? And it's like, oh, well, your torpedo can go to 1,200 meters, not 1,300 meters. Okay, that's all right. I don't mind that too much. You know, that's fine. I'm not going to spend 100 billion quid to fix that problem. Yeah. And it's about in the context and the ability to make those decisions. So I think for me, that's a good example of bringing value as well, let alone, as I say, mentioning obsolescence and you know, reapproaching those legacy systems where they are complicated. You want to capture them, model them so that your downstream engineers, your design engineers, your mechanical designers can understand what you're asking of them. Because when you talk about, you know, defense, let's say time horizons 30, 40 years, you can't just throw a design engineer and say, well, build a new bulkhead, build a new product. They can't even, you know, they could if you gave them enough time. They can, of course, conceptualize that. But again, you're just trying to introduce efficiency and shortcut that a little bit. It's not perfect, but a little bit to make it so that you're a more efficient and sort of lean engineering organization.
But yeah, and I think what's interesting there is with that example you give us where it's brought value, obviously help you address what is a tricky conversational topic just because there are different stakeholders involved in that conversation, right? But what's interesting there is how the outcome of the decision of that means you keep moving forward with the project, but then you've also started to build your requirements further down the line, which is only possible with this methodology, which is very cool.
Yeah, and because you tie that decision making into your requirements process, when the engineer in 10 years' time comes to look at that, they can see that decision.
Yes.
Where typically it gets lost at time, it's stored in a meeting minute that no one ever looks at 15 years down the line. So they don't understand it, so they don't know it's a problem. And again, it's about building that in an approachable way, which is a challenge. You know, there is processes you've got to do there to work out how to do that, but building it in a way that people can pick up so that you don't miss that stuff. You don't miss the opportunity. Oh, we've got to change this processor. We might as well change the sensor at the same time. We're going through it anyway. You know, you're trying to build a more holistic approach so that when those decision points come, you've got the best information to make the right decision at the right time.
Nice, very nice. And then you actually, with what you said there, that leads me nicely onto my next question is, this is what we're talking about is great. And we're hearing about the value, you know, and what you can do with it. But like anything, if it's new to people or they want to explore it or they want to adopt it, all the usual challenges of change and adoption. I think this one in particular, you know, it drives at the heart and starts with engineering, you know, people who are problem solving and coming up with the best processes all the time to be told, well, actually, we need to start maybe thinking about doing things this way. So for you, what would be the biggest challenges for people who want to maybe start to explore or adopt or start an MBSE journey? What have you seen as the biggest challenges to get started?
I think one of the big things is that a lot of people will look at MBSE and they'll be told use it's a language called SysML. Use SysML, you'll be able to work it out. Here's all these books that talk about SysML and how you do MBSE. And I think the way I like to think of it is that's like telling someone, go write a novel. You know English. How hard can it be? You know, you've got to think of SysML as a language, and what you've then got to do is give people the instruction on how to tell the story. And it's also understanding that everyone has a slightly different story to tell. You know, if you look at the textbooks and the guidance, they're trying to solve a very general problem, because systems engineers love to talk in generalities. You know, it's like, it's just a system. So everyone's trying to go, well, this is how you do any system in any way, which is useful, but also very complicated and very like unapproachable. And I think the way I like to work with clients and customers is to say, what do you need to tell? You know, imagine you've got your stakeholders. So you've obviously got a customer who's given you a requirement set. You definitely want to show requirement traceability then. You've also got design engineers who want to understand, well, what's plugging into what's hooking into this. So you go, right, so we know we need like an internal block diagram. And working with those customers to say, because of your needs, this is what we can do, and this is how we can derive value in the short term. I think if you, classic, don't try and eat the elephant. You know, a lot of places will go, we're using MBSE, we're going to do MBSE now. And they just go and do it. And you get all of the very well-meaning and smart engineers going, right, I'm going to do it this way, I'm going to do it that way. And everyone just shotguns. They just do it a million different ways. And you end up with a very fragmented model where you haven't got consistency. So you can't easily have a new engineer approach a problem. And I think where you've got to sort of talk to organizations is to say, yes, you want to do MBSE, take a beat, treat it like anything else you would do with an engineering product. What do you need to do? What are your timelines? How are you going to involve your engineering organization? And then get people to work together on that problem. So you've got people who've done it before, you know, obviously I'd say as a consultant, that's good for me, but obviously experience you've used with it. And then you're also engaging your systems engineers and your wider engineering organization in that change. So you've got to work with them. So you need to do, and then also set realistic goals for how you're going to achieve value. I've seen a lot of places which have gone in and they've tried to do it wholesale. You know, we're going to leave documents behind and we're going to go straight to MBSE. And it ultimately fails because they try and do too much too quickly and they haven't educated the audience. And it's a bit like, as I say, SysML is a language. If you don't tell people how to read it, then they just look at it and go, you've made a load of pretty pictures, but I don't understand what that means. And that's the big thing, is that as engineers, you've got to talk to each other. You know, we are all pretty bad at it, but system engineers have got to brief the other departments they work with, the test departments, the design departments, to say, I'm showing you this. This is what it means. And then also give them open access to look at it. That you can't sort of stay hidden and sort of say, well, we're going to do it in the background, and then we're going to give you a requirement spec, give you a document, give you a model, like, you know, an internal block diagram that shows all these connections, because it will just fail. You've got to let people interrogate the system. And I think, again, that's one of the big challenges. People see, unfortunately, the cost of some of these implementations, and they say, well, we just want a small number of licenses, so only our experts can do it. And I think you've actually got to look a bit more holistically and work out ways you can have all of your engineering teams looking at the model, bought into the process, so that they don't see it as some alien, strange thing. They just see it as, this is the other side of the requirements piece. This is the other side of the use cases, so that I understand, right, this is what I want the product to do, because ultimately that's what we're trying to deliver, a product to a customer to achieve something. And if everyone understands that more clearly, you're only more likely to succeed. But I think a lot of places get very protective and very closed up, and you've got to be open. You've got to be conscious of the challenges you're going to face, and that it's not an overnight flip a switch and you'll be able to do it. It is a process that you've got to invest in and you've got to engage with from the very top to the very bottom of an organization. Yeah, so it is about that company buy-in, and I think what you mentioned there is clearly with something like this, you need everybody looking at it, right? But much like to introduce MBSE and how to have a successful MBSE methodology, again, requirements capture, everyone knows the requirement, to work with. And then what you said there as well, which I thought was interesting, because, you know, I learned from these
these interactions as well, is you need to make sure everyone is going to speak the same language.
Exactly.
Right?
Yeah. Because as you say, everyone knows what a requirement is, but then it's like, to use the system element, what's a block? What's a port? What does this mean? And they've used intentionally strange names, I'd say. I don't love the naming convention sometimes, but it's in a way to kind of make it unambiguous, but also that makes it confusing to someone approaching it. Like I say, people have to understand what's being shown. And it's not all that complicated a lot of the time, but you've got to engage on that piece, because if you just throw it at someone, they'll look at it and go, I don't understand what you're showing, I don't understand the language you're speaking.
Yeah. No, I'm with you. And like I say, there's digital transformation projects, whichever area you're in, PLM, digital manufacturing, MBSE, it's all hard, right? And a big important thing is getting people bought in and having that kind of standardized approach at the start.
And I'm sure you've probably seen that it's not going to solve all your problems. A lot of places will do MBSE and everything will go well. And any digital transformation it's about improving the process, but you're never going to have a perfect process.
Yes.
So I've seen a lot of organizations that have had a problem which occurred not because of MBSE, it would have occurred anyway, but they blame the MBSE process and go, oh, that's why. And it's like, well, what this is showing is MBSE can highlight your problems and you'll still have issues, but we're trying to reduce the number of issues. And also, don't just think about this project, think about the project to rework this in 15 years. And that's we're talking about a long return horizon, sometimes, ROI horizon, which can be quite challenging for an organization to buy into.
Very good. Well, look, I think that's under the slot for what we want to cover for this first one, Tim. Is there any parting comments or words of wisdom you would like to put on us as your final comment?
I think I linking to my last comment, it would be you have to think about MBSE as a organizational transformation and don't protect it. As I say, systems engineers love to sort of look at their problem, look at their thing and think it's a specific discipline. Systems engineering is about producing requirements. I don't think it is. Systems engineering is about leveraging everyone's experience, capturing it in a way that will let you deliver the product as efficiently as possible, which means it's all about communication. And that ultimately is what MBSE is capturing information and communicating it clearly. And therefore, that is the thing that organizations should be looking at, is how do we do that the best way possible? And I think MBSE is like that. It's like 2D to 3D CAD. That's where we're at the moment. There's going to be teething problems, but persevere with it, and there are huge, huge rewards.
Brilliant. So there you go. Thank you. And I think that articulated it quite well at the end there. It's about capturing and communicating, right, through the enterprise of the business. So, Tim, I'd like to say thank you very much on behalf of X Innovation for you joining us to impart your wisdom on us. This is episode 1 of the webinars we're doing on digital thread and digital engineering and manufacturing. If people would like to know more about MBSE or hear more from Tim, we're always happy to take a deeper dive into any more areas in the coming months. So thank you very much, Tim, and we look forward to seeing you guys again.